Algebra 1, Common Core, Unit 4, Section 2, Fractional and Decimal Equations. So 4.1, the video before this, was just solving basic equations. We're still doing that here in 4.2. We're just adding everybody's favorite fractions, decimals. Of course, I'm joking. Most students hate fractions and decimals. They think they're 10 times harder and all that. With the assistance of a calculator, it's really not that bad. And, we'll talk about these kind of one at a time. When it comes to, so as far as procedure goes of solving these equations, it's the same thing as solving the equations we were doing in the last video. You just have decimal numbers instead of whole numbers, but it's still the same exact procedure. You're trying to get x alone. You're going to do inverse operations to move things side to side, etc. So, that's what this little note up here is just saying, that it's just the same procedure. So don't make it any more complicated than it needs to be. So as far as decimal equations go, like this first one here, 2.5x plus 6 equals 2x. Well, just like we did, we're trying to combine these like terms. These are on opposite sides of the equal sign, so I can't just combine them as they are. I got to move one over to the other. Sometimes people hesitate to subtract 2x here because when you cancel everything on the right side, students are prone to make the mistake of thinking that there's nothing over there, it's over. Well, even if you do that, the equal sign doesn't disappear. It would just be equal to 0 then. And so you can do that. I'm not going to do that, however, though. I am going to try to keep something on both sides. Zoom in a little bit. So since I don't want to have nothing over on the right side, I don't want to have 0 over there, I am going to subtract the 2.5x this time. So minus 2.5x on both sides. And that will eliminate it on the left. On the left side, I'll still have 6, positive 6. On the right side, I have 2 minus 2.5x. Now, you could definitely use a calculator here, but you probably don't need it. There's a positive and a negative number. What's the difference between 2 and 2.5 is 0.5. And there's more negatives here. So this would be negative 0.5x. And then we're going to, when you had something like 2x equals 8, the last thing we did was we divided by 2. We divided by the coefficient. It's the same thing here. We're just going to divide by the coefficient, even though it happens to be a decimal of negative 0.5. And so divide negative 0.5, 0.5 if you want, on both sides. And what do you get? Now, without going too far into why this happens, I'm going to recommend at this stage you're just kind of using your calculator here. 6 divided by, now first of all, positive divided by negative is going to be negative. And then 6 divided by half is 12. Again, I could kind of go into a lot of detail as to why that is the case. What's really happening, if I make a little note over here, instead of the decimal, think of it as the fraction. 6 divided by negative a half. And what ends up happening when you divide fractions is you do times their reciprocals. So it ends up being negative 2 over 1, and then you multiply and you get negative 12 over 1, which is just negative 12. Again, I don't want you to stress too much about that dividing by fractions piece right now. We're going to talk more about fractions down here. Remember, fractions and decimals are very similar, if not the same, and you could always turn decimals into fractions, unless it's irrational, but we're not going to give you irrationals here. And you could turn these fractions into decimals. That's not always as easy because something like 2 over 3 would be repeating, and that would be tough to work with. But anyways, once you got x equals negative 12, you could plug that in and check here. But like I said, I would, for those of you who are a little concerned about working with these decimals, just have your calculator next to you, minus 2.5, and you could type in 2 minus negative 2.5 or 2 minus 2.5. And you could do 6 divided by negative 0.5 to get that. It would come out to be negative 12. All right, how about the next example over on the right side here? We see a number in front of parentheses, and we know, just like we have been doing for weeks now, this means the distributive property. So 0.3 times x is going to be 0.3x. 0.3 times 10 works out to be 3. Now, again, I know I'm kind of repeating myself a lot here, but just use your calculator. Type in 10 times 0.3. You'll see that it's 3. And so then it equals 1.2x minus 5. All right, and now we got variables on both sides, an equation with variables on both sides. This case, I think I will minus 0.3x over to this side, minus 0.3x. Don't forget it's 0.3 and not 3, because that'll confuse things. And that'll leave me with 3 equals, I have a 1.2x minus 0.3x. Again, calculator can do it for you, but it comes out to be 0.9x minus 5. And I'm going to add 5 here on both sides. Add 5, and that's going to give me 8 equals 0.9x. Now, even I'm not going to want to, in my head, do a division of, divided by 0.9, divided by 0.9. I could divide by a half easily in my head, but I can't divide by 0.9. I have a calculator here over on the side, which you can't see, unfortunately, but 8 divided by 0.9, it tells me it's 8.8888888 repeating, basically. Don't forget the math enter feature in your calculator is a really helpful feature that is telling me the answer is x equals 80 over 9, which is a pretty weird answer. My guess is I actually probably made a mistake when I created the problem. I probably didn't want an answer like that, but it doesn't matter. It's okay unless I made a mistake somewhere. Say 0.3x, 0.3, 1.2x minus 5. Minus 0.3 would make it 0.9. This was probably supposed to be 1.3 this way. It just came out to be 1. 1x is just x, and then get x equals 8. But, that's all right. This problem is more fun this way. Add 5 to 8, divide, yeah. So, 80 over 9. No big deal. All right, how about these down here? So when you're working with fractions, I would kind of think of it as a different procedure. There's something that we like to do that's called clearing denominators. See, what people don't, if this was just x minus 2 equals 3, it'd be great. Easy question. Right? It's this denominator of 4 that makes this question a little bit more challenging. So the way to do that is we can eliminate the denominator. And the way to eliminate a denominator is to multiply it out. Remember, a fraction is a form of division. So when you see x over 4, that means x divided by 4. And so to undo something, we do the inverse, and that's multiplication. So what I like to do in these problems, yes, I could add 2 here, and there's a couple of different ways to solve this. Let me actually show you 2 different techniques. In the first technique, I want to multiply everything by 4. There's 3 terms, 1, 2, 3. And I'm going to multiply all of them by 4. So let's see, let me first multiply by 4 here, multiply by 4 here, and multiply by 4 there. The equation that has the denominator 4 now has 4 times x divided by x. They cancel each other out, and I'm left with just x. It's no longer over 4. That's the whole point. And then this negative 2 times 4 becomes negative 8, and this 3 times 4 becomes 12. Now it's a simple equation. Add 8, we get x equals 20. The other option here, let me show you this problem again. X over 4 minus 2 equals 3. Some people want to add 2 because that's easy. I could move that 2 over. And when I add 2, what do we get? We get x over 4 equals 5. Well, now you have something that's called a proportion. A proportion is when you have a fraction equal to a fraction. Now 5 is not a fraction, but we know we could always put it over 1 and make it a fraction. A proportion is when you have a fraction equal to a fraction. And the way you could solve a proportion is called cross multiply. So I have x times 1 is x equals 4 times 5 is 20. So if you have fraction equations which you could turn into proportions, you could do cross multiplication. Now you can't cross multiply right away. It's got to be a single fraction equal to a single fraction. Like in this next example, I have a fraction here and a fraction here, but I can't cross multiply, at least not yet, because I have a plus 1 and a minus 4. This one's going to be tough to cross multiply, and this one I'm going to suggest clearing your denominators here. So let me do this last example for you. This 4-3 here, these notes here, this is for the next video. So let's see. The first thing is a denominator of 3. I want to multiply that out, so I'm going to multiply everything times 3. And this first one, the 3 times divide 3, that cancels out. I get just 2x. Plus 1 times 3 is 3 equals 3 times x over 2 is going to be 3x over 2. And minus this negative 4 times 3 is going to become negative 12. So exactly like I did here is multiply out the 4. Well, here I multiplied out the 3. Well, I have another denominator of 2. So now I'm going to multiply everything by 2. So times 2, times 2, times 2. 2 times 2x is 4x. 2 times 3 is 6. The one that has the denominator of 2 just cancels out because it's a times 2 divide 2, and I just get 3x. Mistake there, sometimes people cross out that denominator and then again multiply by 2. Don't do that. Just multiply by everything by 2 once. And this one's negative 24. And now we got a basic equation like the last video here. I'll just do this one real fast for you. Minus 3x minus 3x. That's going to give me x plus 6 equals negative 24. Minus 6 minus 6. X equals negative 30. And just like the regular equations from yesterday, I mean, these are still regular equations. They just have different types of numbers involved. But you could always plug them in and check your answers. And so that's it. When you got decimals, just work with decimals. Let your calculator help you out. If you got fractions, if you could do proportions, cross multiply. But if not, just multiply out that denominator one at a time. Get rid of it. And then don't forget to check your answers. All right, that's it for 4-2. See ya.